The density matrix method is another kind of method where we can study the interaction of light with matter. And previously we discussed about the probability amplitude method, and now we are interested to study the density matrix method. In quantum optics, the density matrix or density operator is a tool to describe the statistical state of quantum system. This is important. Statistical state. This point is important because this kind of statistical state is not present in probability amplitude method. So this is the statistical state. How? Let me have a state. For a given state, there exists a state vector. We have a state vector for any given system, which contains all possible information about this system. If we want to extract a piece of information from this system, then we must calculate the expectation value of the corresponding operator. Let we have a state this, and if we take the expectation value of the corresponding operator, then quantum mechanically the expectation value can be written like this. And we all know about the expectation value of a corresponding operator in quantum mechanics. But in many situations, we don't know psi, but we know the probability, p psi, the probability of finding the system in state psi. So p psi means the probability of finding the system in state psi. Then for this situation, we must take the expectation value of this, which is known as ensemble. There are many particles, then we must take the ensemble of this system. And the ensemble of this system must be written as summation of psi, p psi, and the expectation value of this. And this is known as quantum statistical system. We know the completeness relation for different many states, which is equal to 1 summation of n. For two-level system, you remember for a two-level system like A and B, the completeness relation we have written AB plus AA plus BB, which is equal to 1. But for there is a many number of states, then we can say that the summation n, which is equal to 1. Putting this value 1, the value of 1, which is equal to this, here in this statistical expectation value. Let's see, if I write this first and this second, so no problem. And then I put summation of psi and p psi inside here, summation of psi and p psi. Then this term is very important, and this term is known as rho. Then this summation n, a, rho, and n. And then this is known as summation n of a and rho and n state, and also known as sum of diagonal elements. This is also known as sum of diagonal elements. Now, the most important thing that we have considered this rho. This is important. This rho, which is equal to summation psi p psi and psi psi. This is very important term, and this is known as density operator. This is known as density operator.